Terminal debugging. Before debugging, we first install the branch claws, debug the branch claws, and bring over the wires we cut earlier. Loosen the fixing screws of the secondary rotation. Then, the spacing of the secondary rotation should be closer than this wire, about 0.15 millimeters. If the spacing is too large, it may grab two wires. If the spacing is too small, it will pull down all the crimped wires. This will cause the terminal products produced during manufacturing to burn. So it needs to be appropriate, around 0.15 millimeters. Otherwise, after adjusting the spacing, lock the fixing screws. After locking, the next step is to install the wind rotation. The wind rotation is mounted on the wind rotation bracket with two 4x16 fixing screws. After installation, we need to check the spacing of the wind rotation. Is it aligned with the center groove of the mold cutter? This point is crucial and must be accurate. There is a center groove in the mold cutter which serves as a reference. So after installing the wind rotation, it should be vertically aligned. If it is off to the left or right, adjust it with this screw. After adjustment, align it properly. Then we push the screw over and tighten it. This way, next time we change the direction, we won't need to realign it. Just fix it directly and it's done. However, if we change the wire diameter and need to readjust the spacing, we need to check if the spacing aligns with the center line of the mold cutter. This is a vertical line. After installing the side shaft, first, we use our socket wrench to turn the eccentric shaft at the back of the terminal machine once. Turn it once and check if the tension is too high. This means the tension is too low and could damage the blade. If that's the case, we need to loosen the fixing screws, which are the fixing blocks of the adjustment knob. After loosening, turn the tension counterclockwise to reduce it. Turning in this direction can reduce it, allowing it to turn normally. Now we put the terminal on. Then change the automatic mode of our frequency converter to manual mode. I press again to turn the light red. Next, we will test our current tension. Follow the middle cushion. Turn in the direction we normally press the demi. Alright, let's manually compress one. If we can compress this terminal, we'll check if these screws are tightened. If the tension is too low, we need to adjust the knob. First, loosen these two M6 screws, then twist the adjustment knob in this direction. Insert the wrench into this hole, twist in this direction. The tension will increase, twist back in this direction. The tension will decrease. We twist from this hole to this hole about 0.2 millimeters. We adjust according to the actual situation, and we adjust that much. Another thing is the drop of our terminal, and there's no drop between the outer paths. If your outer path is pressed too low, we need to adjust the mold. Loosen the screws fixing the blade, then turn the adjustment knob to the other side. We push the blade down to the maximum scale, while the 8 on the other side is the highest scale. We choose a suitable face based on the actual situation. To ensure the terminals meet our client's requirements. After adjusting the tension, we also need to lock all the screws. The adjustment knob is to eliminate the gap between the head and the mold. This adjusts the height of our outer blade, and this adjusts the gap between the head and the mold slider. If the gap is too large, the collected tension will be inaccurate. This line is for a pressure detection device. And the same applies here. When we push the mold inside, it should be smooth. Then we switch to another face. We should feel friction between this face and the bottom of the mold head, and there should be no gap when moving up and down. We choose this face, then lock the mold latch. After adjusting the tension, next we reset the machine and return to the origin. After returning to the origin, switch to automatic mode,